Chapter 6, number 21. A spring with a force constant of 120 newtons per meter is used to push a 0.27 kilogram block of wood against a wall as shown in the figure. Find the minimum compression of the spring needed to keep the block from falling, given that the coefficient of static friction between the block and the wall is 0.46. And then does the answer to this part change if the mass is doubled? Why or why not? They actually give us a free body diagram. I don't like it, so I'm going to do my own. But, so we have our block. I don't like the names they use. I don't want to use the names we've been doing standard-wise. So we have, for instance, the weight pulling down, Fg. We have a normal force pushing out from the wall. We have a frictional force, which is tending to stop the block from sliding down the wall and therefore points upward. And then we have a spring force, and the spring force is, because the spring is being compressed, the spring force pushes against the block. So we get something like that. And then we can do our standard Newtonian analysis. So from the free body diagram that I've drawn, we have the sum of the forces in the x direction is the spring force minus the normal force. And the sum of the forces in the y direction is the frictional force pointing upward, but then minus the weight pulling downward. And from second law, the acceleration is 0, so we end up that from Newton's second law, both of these things are 0. So we can combine those to say the spring force minus the normal force is 0, and the frictional force minus the weight is 0. And then what we also know is that the frictional force, and this is not a Newtonian law, the frictional force is less than or equal to mu static Fn. We also know, of course, that Fg equals mg. And we know that the spring force is k times the stretch, or in this case, the compression in the spring. So if we put all of these sort of together again, we end up with something like, let's see, we have that FF equals mg, but FF is less than mu Fn, so less than mu s Fn, so mg is less than or equal to mu times the spring force, which means mg is less than or equal to mu s times k s. A lot of s's there, sorry. So we can solve this and say that mg over mu s k is less than or equal to s. So that if we put these sort of together, we can turn this around and say s must be greater than or equal to mg over mu static times the spring constant. So s must be greater than, and now we just put in our values here, 0.27 kilogram times 9.81 meters per second squared over 0.46 times the spring constant, 120 newtons per meter. So the distance s must be greater than 0.04798 meters, or s has to really, with sig figs, be greater than 0.48 meters, or 4.8 centimeters. That's part A. Part B says, does the answer change if the mass of the block is doubled? And this is actually a nice easy thing, because we can look right here and say, well, we have the m. And so, yeah, if we doubled the mass, we would double the compression, the minimum compression, which makes sense. The doubling maybe not, but certainly should go up.